right, hello everyone. I'd like to welcome you to today's webinar on design thinking. My name is Shannon Tim and I'm the Director of Alumni Relations at the Wisconsin School of Business. This webinar is part of an ongoing series that we host, but we are very happy to be partnering with the College of Engineering and the School of Human Ecology for today's topic on design thinking. So my role today will be to help moderate our Q&A session at the end of today's presentation. Please feel free to submit your questions at any time in the Q&A box, and we'll leave time at the end to have our presenters respond. We will also be recording today's session and providing a link to that recording following today's presentation. So with that, I would like to introduce today's speaker. Giustina Parisi is a lecturer at the Wisconsin School of Business. She has over 15 years of industry experience in this field, with roles at Procter & Gamble, Kraft Heinz, American Family Insurance, and Exact Sciences, where she has been able to identify business solutions by overlaying consumer insights with business management practices. She is also a double badger, earning both her MBA and bachelor's degrees from UW. Second, we have Lennon Rodgers. He is the director of the Granger Engineering Design Innovation Lab at UW, which includes a makerspace, machine shop, and a set of interdisciplinary design programs. He earned his PhD and master's from MIT and his bachelor's from the University of Illinois, and he's previously worked at MIT and NASA's Jet Propulsion Laboratory. And finally, our third speaker is Michelle Kwasny. She is the academic director of the Masters of Science in Design Plus Innovation at UW, which is a hands-on program in human-centered design. Prior to that, she worked at IDEO, leading research focused on service design in the public sector and education. She holds her master's from Georgia Tech and a bachelor's from Indiana University. So Giustina, Lennon, and Michelle, thank you guys so much for being here. I'm certainly looking forward to this session. So with that, please take it away.
Awesome. Thank you, Shannon and the whole team for having us, and thank you all for joining us today. So I'll kick it off here. We have a couple of learning goals for this session. We would like for you to understand the basics of the design thinking process. We'll talk about some things that will hopefully help you develop a prototyping mindset with a bias for hands-on action. And hopefully you'll be able to identify opportunities in your own work where you can implement design thinking and prototyping. So we have a packed agenda to accomplish those things today. So we'll start with a brief introduction to design thinking. Then Giustina will go into a bit more about what a prototype is and why we care to talk to you about it today, why it's important. We'll go through a few different ways to prototype or to look at prototypes as you go through the design process. We have a leave behind a worksheet for you all to take back into your own day-to-day work. And then at the end, we'll touch a little bit on that new master's degree that Shannon mentioned earlier. So let's get into it. Quick introduction to design thinking. So normally this is where in the room I would say, hands up if you've heard of design thinking. So hopefully some of you all have, and I'm going to introduce it using a definition. So this is one of my favorite ways to talk about or to introduce it to folks. And there's a number of reasons for that. But first, so this is Sandy Spiker, the now CEO of IDEO, a design consulting firm. And it says, design thinking is about being aware of the world around you, believing that you play a role in shaping that world, and taking action together towards a more desirable future. So there's actually three reasons I like this definition. The first is that it nicely describes the mindsets and behaviors of a design thinker, or someone, basically a design thinker is anyone who thinks and acts like a designer. So design thinkers are human-centered. Notice the world around you and the people involved in that and what's happening. Experimental, so actually taking action, making things real, learning, leading through doing. And that's a lot of what we'll talk to you about for the rest of the presentation too. Design thinkers are collaborative. They work together to get things done, to make those things. And finally, there's a sort of an inherent optimism that there's a better future out there. But the second reason I like this definition is that centerpiece there, believing that you play a role in shaping the world. I think, psychologists call this an internal locus of control or agency, but that is critical to the design thinking process. It's the belief that you play a role and then taking action towards changing up the world around you. And the third reason I like this definition so much is that those three pieces, being aware of the world around you, believing you play a role, and taking action, really align really well to the three sort of phases of design thinking: inspiration, ideation, and creation. And often, when folks present design thinking, or if you look at the toolkits, you'll see this more in terms of process. So as we map out this process across a journey, it looks like that, exactly. So this is sort of mapped out linearly, and these are the basic steps, if you will, of the design thinking process. So the inspiration phase is really about articulating the challenge ahead of you, learning as much as you can about the people and the places and the interactions involved. The ideation phase in the middle there is about coming up with new and innovative things to try. And the creation phase is about getting tangible and testing and refining ideas in order to learn. So each of these phases, you'll see the squiggly lines there has a diverge phase where you cast a wide net, look around you, and explore things you might not have considered, and then a converge phase where you hone in on what really matters. And you'll notice that those get smaller and smaller as you start to learn more throughout the process. So today, we want to focus in on more of the ideation and creation phases, where getting tangible is absolutely critical to the process. So I'll turn it over to Giustina now to take you through that.
Thank you, Michelle. So Michelle alluded to this, but I'm going to share what really is a prototype and why it's important. At its essence, a prototype is a question made tangible. And there are a lot of questions your organization has that can be answered through prototyping. Prototyping's about bringing the conceptual or theoretical ideas to life and exploring their real-world impact before finally launching them into the world. Prototypes can be anything from sketches on a napkin, virtual reality, wireframes, setting up a pop-up store, just anything that lets you make your ideas tangible and testable. So on the screen, you can see the breadth of prototypes available in just this one instance of Dyson creating a prototype for a vacuum, from low fidelity all the way to high fidelity with 3D printing. There's just a lot of opportunity for us to lower the risk of exploring through prototypes, asking the questions we didn't think to ask as somebody's interacting with their solution, and having the ability to make ideas tangible so that you and others can engage with them. With a 90 to 95% failure rate of new products, we have to ask ourselves how we got all the way to launch only to discover one or more of our assumptions were wrong, having spent valuable time, money, and resources, but ultimately having no customers. This is where design thinking, and more specifically prototyping, comes in. By testing your prototype with real people, you get to interact with them iteratively and examine and refine our ideas early in the product development process and launch more confidently. Design thinking provides a set of tools and approaches for properly testing and exploring ideas before too many resources are used. We prototype so we can build a think. Prototyping and design thinking provides that bias towards action, where building and testing is valued over meeting and discussing. By quickly building and testing, we can maximize the impact and minimize costs. Prototyping to test assumptions helps the team avoid emotional attachment to the final idea by allowing others to continue to build and improve on our solution. We also prototype so that we can fail early to succeed sooner. Prototyping quickly and frequently is the best way to test your assumptions, learn about your users, and improve on your ideas. Using prototypes can advance your design process through milestones. We can start with low fidelity prototypes early on in the development process so that we can start to explore that solution. Higher fidelity prototypes can be used as we move to refinement. Prototype also allows us to avoid miscommunication. Your person's actually seeing what you're trying to develop, and helps you iterate through and answer questions through evidence and feedback. Now that we know why prototyping is important, let's consider how. So prototyping isn't just a one and done create your solution. It really is a cyclical process that starts with your assumptions and helps you problem solve through your innovation or design process. We frame our assumptions as hunches and questions, and then informed questions, and then design prototypes we can test with real people to answer these questions and build evidence. It really all starts with a question built from your assumptions, and that right question drives that solid prototype. The next you determine what you can make or show people to test your assumptions. A prototype allows you to physically express that idea or solution and produce deeper understanding. Finally, we consider what we'll observe or measure so that we can feel confident in our assumption or answers to our questions. When we innovate, I know we all have a lot of assumptions that go into determining our solution and how it will be a success. And often it can just be helpful for us to just jot down all those assumptions and determine how certain we are in those assumptions and how true we believe they are based on the evidence we have today. You can take that list of assumptions and turn them into questions we need to answer. Prototyping starts by asking the right questions. What do you need to know to de-risk your idea? Your hunches could be questions, hunches like you like to confirm, like a feature they want or a need you anticipate they have. Areas that you're less confident in or may pose more of a risk, like something you know from your own experience, but you want other people to confirm. It could also be assumptions that you've made that have to be true for your product to be a success. Like you have to be able to hire the right people or that the technology works. It's important to determine what you want to learn before you create your prototype. Being clear on the goal will help you determine the kind of prototype you need, whether it's low or high fidelity, and the type of elements you need to include in it. We build our prototype with purpose. Consider what we can make to show people in order to test those assumptions. We're not just building the solution. We want to consider creative ways to express an idea or solution in the most efficient form to further exploration, testing, and refinement. When it comes to testing our prototype, we want to establish metrics that allow us to answer our questions. What needs to be true for you to feel more certain of your assumptions? Obtaining your right participants, whether you're recruiting or observing in the environment, is just as important as determining your prototype. Whom you test your prototype on will affect the usefulness and relevance of this feedback. How you solicit feedback from your participants will depend largely on the type of prototype you've built. So we've gone through the why and the how of prototyping, and Lennon and Michelle are going to start to talk through the many different ways that we can prototype throughout the design process and the different areas of questioning and assumptions that we have when we move into prototyping.
All right, thanks, Giustina. Yeah, there are many different ways to prototype throughout the design process, and it really depends on the question you're trying to answer or the assumption you're trying to prove. And I think Giustina kind of talked about that. We'd kind of like to break that out and talk about it in a little bit more detail. And really it is the question or assumption about the needs of people, the constraints of technology, or the requirements of business. And so these are fairly traditional standard ways to break out different areas of design, but it also happens to be our respective areas, Michelle, Giustina, and I's, our areas in terms of technology, business, and design, and human design specifically. But in other words, is your risk about people, how they use or approve of the design? Is it about the technology or the performance specifications? Or is it about the business and the ability to provide value through the product or service? So let's dive into each of these. We're going to spend a few slides talking about them. And Michelle will kick us off and start detailing and talking about human desirability.
Awesome. Thank you, Lennon. Yeah, so I mean, really all three bubbles are about humans, but there's a lot of different ways to kind of slice and dice how you get feedback or how the assumptions about humans come to life. So I just have a couple of examples to share as a way to get us started. So the first one here, so this is an example of a project that IDEO, a design consulting firm, did for a company called Gyrus. So Gyrus was interested in making a new nasal surgery device. And of course, they wanted this thing to be easy to use and comfortable for surgeons, but also safe, for the patients going through surgery. So one of the questions early on in the project was, how could a surgeon safely hold a device? And so, prototype that question, taking a lot of found objects like sticks and scissors and tubing, mocking up, as you see in the image there, a lot of different ways to hold a device. And, the test for this kind of thing early on in the project, have people pick these things up and hold them and report back on what's comfortable, what isn't, how easy were they to use, what improvements might they recommend. So the point here is that, in this kind of testing, prototypes ask the questions you didn't think to ask early on. So things like, oh, where might the tubing go around my hand? Or what angle is most comfortable for my wrist? And you might not know that, before you actually mock up something. The next piece is same project and sort of same question, but Giustina talked about before how miscommunication can be sort of put to rest with a prototype. So this is an example of the same team in a meeting, board of directors meeting, talking about what angle might work and what features this device should have. And actually just a designer grabbing, this is an old example here, clearly a film canister, but a marker, a film canister, and a clip, and saying, is this what you mean? So it can be as easy as actually just getting physical or tangible in a meeting. And it definitely, prototypes make ideas tangible so that they can, other people can engage and that it can be communicated in an efficient and effective way. And then third example of this same project. So once you get past the sort of early prototyping phase with found objects, as you get further along in the project, then you start to be able to compare options and really look at the details of the mechanics and put time and energy where you think it has the most potential. So here, same question, how might they hold it? Now you're seeing 3D printed prototypes, a little bit higher fidelity, a little bit more expensive, but different options for surgery. For models. And here actually the test gets more sophisticated too. So we're later on in the project, you might actually have a mock surgery where a surgeon actually goes through an entire surgery and then reports back. You might also have some quantitative reports of, accuracy, safety measures, et cetera. So you get a little bit more sophisticated with how you test things as well. So the next slide shows the final device. So not too far from that film canister prototype from that meeting, but all of those prototypes helped, direct and were the guide rails for the delivery of this final design. So that is one example of a human focused prototype, but that was very functional, right? Physical thing. How do we hold it? How do we interact with it? The other point I want to make here is that humans are emotional beings, and so part of prototyping can be emotional as well. So this project was how to create a digital reader, sort of an ebook that actually embodies the best parts of physical books. And so here the team was interested in designing a back cover, really just an aesthetic part of this e-reader that would signal, paperback books. And so what they did was sort of an origami exercise, right? They took a bunch of paper and folded them into different formats. And then they stepped back and they said, what emotions do we feel? Do we feel like any of these cue in to the physical book better? They brought people over and said, what do you think? And really it was just looking at these folded paper that they were able to kind of narrow in on a design that they thought worked best. And so, prototypes also create emotional experiences. And you'll see on the next one, there we go. The final design of, this is the Kobo Aura device, but it's a bit like, the pages of a book folded back as you hold it. So again, just an aesthetic prototype, but a good one for that learning as well. So whether it's about how humans use something or how they connect with something emotionally or everything in between, prototypes have help us get tangible and have something to react to early on in the process. So that was human reaction. And now we'll talk a little bit about tech feasibility. So I'll hand it over to Lennon to explain more about that.
All right, thanks. Yeah, here's just a picture, an example of a technical risk. And it could be, I'm kind of sticking with the vacuum cleaner theme here. It could be an autonomous vacuum cleaner, like the Floor Roomba there shown in the small picture. And early on, there may be some high technical risks in questions like, can the electronics and algorithms be created to result in an autonomous vacuum cleaner? You know, what type of movements are needed? What are the sensors, the algorithms? But overall, it's really just this question of, is it actually technically feasible? And I think we've seen with the vacuum cleaner that they have determined it has, and there's a lot of other products that have kind of capitalized on that technical aspect of these products being figured out and developed. But the other interesting thing to note here is that with technical prototypes, it's usually when you need an engineer. So if you're kind of thinking, hey, this is something that an engineer might be needed, that's probably something along the lines of a technical risk. I also want to mention, working in an interdisciplinary setting, I've seen it's kind of unique to engineering in some ways that we really look at design through the lens of risk mitigation. And so when I was a grad student taking a lot of design classes, a lot of the design theory and design process that we learn is really an alternative story or other tools used to mitigate risk. And so a lot of times engineers kind of think of it in that way. And as you move along the design process with a technical risk, the risks kind of go from very high, usually, those are the ones you're focusing on, and you hope that they reduce and become lower. The performance specifications also start out quite uncertain, so you may not know exactly what are the performance specifications, and then through this technical prototyping process, they become more certain. But like what Michelle showed before, even with technical prototypes, you start with very low fidelity prototypes. So this could be basic platforms with wheels, motors, a few sensors, onboard computers. I often just go into my closet of things and start pulling from what's available and quickly available. I steal from other components, things that already exist. But really the complexity of the prototype will become more complex. It will increase, and also the fidelity increases with time. As the risks are better understood and as the functional requirements are either better understood and or achieved kind of through that process. In terms of kind of the design and testing side of things, the technical prototype often starts out very functional, and I kind of mentioned that. It's bulky, very focused on solving some specific problems, technical problems. But then it will really drive towards a more user-friendly design, and it will incorporate and really interface with all the things that Michelle started talking about. So prototypes will also start as more of a benchtop test. So when you start doing things, it might be in a very controlled environment, literally on a benchtop. But then again, it will drive more towards real world tests that consider both user and market testing and environmental considerations. And that's similar to what Giustina will talk about in a second. So to kind of dig into a little bit more of different types of technical prototypes, I just wanted to give this framework to how you might think of different types of technical prototypes. So there are certainly different approaches to when you're making a physical technical prototype or an analytical, which I'll talk about. We most commonly think of technical prototypes as being physical objects. So I kind of have some images on the upper part there where it says physical, and I'll go into those in a little bit. But most engineers know, and kind of what we're trained to do, is that there are also a lot of analytical prototypes kind of shown on the bottom of the screen. And these can be either calculations on paper, spreadsheets, complex computer simulations. They're all with the same idea of trying to mitigate some of the technical risks involved. An analytical approach might be the best approach if the underlying physics are well understood, and that's kind of a key aspect. You really have to understand the physics. And the design must benefit in some way from exploring a wide range of design parameters. So analytical models allow you to really explore the range in the design space. So we have the physical, we have the analytical, those are kind of shown on the top and the bottom. But even within these categories, you can create prototypes that are either more focused or comprehensive. What's shown on the left is more of a focused experiment. So this could be some focusing in on, for example, to stick with the vacuum cleaner approach, it's a simulation of dirt right at the section of the head. And this could be a computational fluid dynamics model, very focused on one area. And then on the right side, a more comprehensive would be looking at the entire vacuum cleaner. So this would be looking at, again, maybe some type of computational fluid dynamics, a computer simulation of the entire vacuum cleaner. So it's the whole system. And those are often very complex, these comprehensive prototypes. So you typically try to avoid those unless they're essential, especially the analytical ones. So you can kind of go to all these different quadrants, and depending on which area you're looking at and what would be the best approach, you kind of pick that specific type of technical prototype. So the next slide kind of goes back to the Venn diagram, and the final type of questions and assumptions we'll discuss is related to business viability, which Giustina will now explain.
Thank you, Lennon. We can also validate business assumptions through prototyping. You can see I've listed a few business assumptions that we often have. Does our messaging or solution resonate in market? Is the addressable market big enough? Does our business model fit? And can we affordably acquire customers? Sometimes teams, and I have fallen in this trap myself, may fall into using a napkin exercise to validate some of our business assumptions. Meaning we can look at some of our market research data and understand that we surveyed maybe X% of our target market population said they would buy a product. We can start to look at that anticipated demand and calculate that break-even point and start to hypothesize that beautiful hockey stick demand curve and how successful our launch is going to be. I'm here to tell you it can be a lot more powerful if we use prototypes throughout our design process to answer some of these business model questions. Sure, 89% of people said that they would use our service, but what would they actually do? And building a prototype gets our solution out into the world and gets us a better understanding of how it works. So with these listed business assumptions, with prototyping, we have a huge opportunity for us to be able to test business assumptions and ultimately measure behavior. Early on in the development process, choice exercises over here on this low fidelity end help us think about and answer questions related to features and price points. We have low fidelity digital images with a description of the product or service, and it can help provide evidence for assumptions we may have about consumer preferences within a competitive set or the value of a particular feature. Even though you may not be face-to-face with someone, oftentimes these choice exercises, again, are starting to help us understand behavior by forcing people to make choices. And then we can start to think about how that might play out as we move up in our development process. Virtual prototypes allow us to start to visualize the context digitally, and we can begin to understand behavior by having people kind of immerse themselves, albeit virtually, within that environment. Live prototypes involve releasing still rough concepts into context where consumers would eventually encounter them through their daily routine, such as an app store or on a store shelf, with all those associated choices and distractions. The key here with a live prototype is you're not building your final solution. It's just enough fidelity for it to appear in the context or in the environment that you were anticipating your product or solution to be. It helps us understand how environmental and situational factors will affect the appeal or visibility. We'll observe what people do and what versus what they say they'll do when they encounter your product or service. A live prototype is a great way to cut corners relative to a full pilot or an in-market test. And speaking of in-market tests, that's really kind of the end result. Before you move to scale, you want to try and get as close to the right solution with a high degree of certainty, where risk has been iteratively reduced throughout that design process. With an in-market test, we're really striving to deliver on the true experience before we move to scale, before we move to launch, to understand where we might have some additional tweaks so that we don't come out at launch with some of these assumptions that we've had along the way falling short and not having enough evidence built up throughout the process. Now we've shown you 3 areas of questioning or assumptions that you might have. Michelle comes with a design background, Lennon engineering, and I shared some business considerations to consider. Pulling together a diverse group with different backgrounds can really help us explore the range of questions and bring in a lot more creativity when we think about how we can start to show people and have them interact with our solution to build up that evidence and certainty throughout the design process. Regardless of the question, most prototypes have a similar effect. Throughout the design process, we move from less certain to more certain. And as certainty increases, as does the fidelity of our prototypes. They become more realistic as we test and measure to launch. You can see in the project timeline, we start with what could be and move to what should be. We're less certain of our human needs. As Michelle started to build through those prototypes, we became more certain of what our design target needs from our product or service. We start with considering many concepts, many ideas, and we move to refinement, and we start to consider few concepts and really start to center in on that final solution. That lower fidelity to high fidelity really played out in all of the different areas or assumptions that we came up with. And then we have that lower cost to change direction. You want to start that early on in the process where you have the lower threshold where you can really start to pivot and change on how you're going to develop that solution. And then move to that refinement where you start to build out more of those concrete technical prototypes or real life designs so that higher cost to change direction is really mitigated. And then that low cost or found elements to create those prototypes, then moving to the higher cost prototypes where you're really narrowing and I'm more certain of what that final deliverable is going to be. Anyone can effectively prototype. And Michelle's going to run us through a worksheet that's meant to help you use prototypes in your work.
Yes. Yeah, so we've taken you through quite a bit. And now our hope or our challenge for all of you all is that you take this back with you and you think about anything that you're creating or doing that is new. Think about how to get a prototype out there and into the world. So hopefully this worksheet will help. So here it is, and there's a link on the screen. You know, if you go there right now, you can access this worksheet. It will also be sent in some of the follow-up emails. So don't worry about jotting this down. It will be available to you. But it really just follows the cycle you saw earlier in our presentation, where the first thing you do is think about the question, what assumption or hypothesis or idea that you'd like to test. So writing that down and getting that out. Then based on those questions, thinking about what prototype makes sense. What will you make? How will you get tangible? How will you make it real? And sometimes things aren't, you know, a physical design or, you know, a tangible thing. So how might you actually get the idea out in there into the world? Is it a concept board? Is it role playing something? And then what evidence will you collect? How will you know this thing is successful? You know, is it just observing smiles of people walking by? Is it, you know, asking people what they think? And those are really the three main elements that should be involved. Just a couple of quick tips as you all go out and do this on your own. 4 things to keep in mind. So the first one is show, don't tell. So whenever possible, you know, create a prototype that someone can interact with and let them use it and show them how it will work, but don't overly explain it. Your goal is to get someone to experience it rather than relying on an explanation. Second one, visualize multiple options if you can. A great, you know, having one thing and saying, hey, what do you think? You know, someone will say, good, you know, great, I don't know, but having a few options there to say which one resonates the most, or which one is easiest, or whatever your line of questioning is. People have an easier time answering that and giving feedback on that. Don't defend your prototypes, so let others play with them and use it as a way to build empathy. So whatever they say, you know, and whatever feedback they give is their truth, is right, and you know, just take it and build on it. And then that sort of dovetails into the last one, be open to feedback. So you are doing this to avoid premature attachment to an idea. So you want to get rid of ideas that don't work or resonate early on, and that might be your favorite idea, but it might not be working out there, and that's okay. Let the prototype stand on its own and then be open to getting feedback of all kinds. So that is it. We hope that you'll take that and take it back with you. Just wanted to say briefly, for those of you who are interested in prototyping or I guess design thinking or human-centered design in general, Shannon and others mentioned this at the beginning, but they wanted to make you aware that there's a new master's on campus that's interdisciplinary. So it's the Master's of Science in Design plus Innovation, or MDI, as I like to call it. And students in this program learn innovation skills and design thinking processes from 5 of UW-Madison's great schools and colleges. So we have them listed here, but engineering, business, human ecology are just 3. We also include and have great courses and faculty from our information school and our art department too. So check that out. The website is over there on the right, and reach out if you want to learn more about that. That is it. Hopefully you all learned something, and we'd love to answer any questions you have.
Yeah, thank you all for that presentation. I think really interesting, and Carly's scratching the surface of all that there is to learn. So I think we can open it up for questions now. As a reminder, if you do have a question, you can put it in the Q&A box, and we'll get to as many as we can before we wrap up for today. So we have had a question come in about how you can use design thinking on intangible ideas. So I think you all talked about some great physical prototypes that you can make, but what if you want to do a prototype for something that's intangible? Can you speak to that?
Is it more in terms of like a service?
Yeah, the specific question was, can one use design thinking on intangible ideas?
I mean, Michelle, I think they asked us before, you had mentioned it in your talk, but I don't know if you wanted to expand on what, because you had mentioned that.
Sure, it's funny. These are somewhat like, who's gonna take the question? Yeah, so I think prototyping can be used for tangible, intangible ideas. Giustina mentioned services, and those are sometimes things where, yeah, the service or the delivery of something is really what you'd like to prototype. And typically with something like that, my mind often goes to actually role playing something out. So creating roles or people that take on different roles in a process. And then, you might write scripts of things for them to say. You might prototype an interaction with someone, and you can do that, sort of person on the street style, or you can invite people into a space, or you can just do it sort of designer to designer a little bit, where you prototype an interaction. You might find that you need some assets to go along with that, like a card or a photo or something that would help support that interaction. So one example of this is a project from a while ago, prototyping a new, basically turning a pharmacy in like a Walgreens or a CVS into more of a place that would consult on your health and wellness. So that was less, it was a physical space, and how do we design the space? But more than that, it was how do we design the interaction and behavior change from pharmacist to person being consulted, or person coming for the consultation. And so again, there it was role plays and scripts, and they prefer standing or sitting, and some configurations like that. So so that's an example I can think of. I don't know if Lennon or Giustina, you have other examples to draw on.
Yeah, sometimes we'll actually, if we have a behavior theory in mind, that's kind of something intangible where we believe people will behave in a certain way, we can start to rearrange an environment so that we can bring out and understand that behavior. So the way somebody is going to be shopping, what are they going to be looking at? Those types of examples where you want to better understand human behavior, and you can think creatively about how you can change the environment. So it's creating that prototype within the environment so that you can understand behavior. So that's another example where I think of you can get creative in understanding how you can start to arrange what people are going to experience. And then it ultimately is about your metrics and what are you measuring and what do you want to learn? What question are you trying to answer?
So maybe a related question to that, Giustina, is like knowing when to stop. So someone asked, how do you balance cost with completing this process? And what method do you use to determine when to stop?
Yeah, that's a really great question. And it's the balance between certainty. So how sure are you in your assumptions? And I would say you don't have to go through and test every single assumption that you have. It's kind of weighing like, this is a critical assumption to our success and starting to think through that balance. So planning out, it really is like, how confident do you feel at launch? Do you feel like you've gone through your riskiest assumptions and you feel confident that what you are assuming you've answered your questions as you move to launch? I think that's where it comes in. It really is do you have a sense of what's going to happen at launch? And then you just have to put it out there in the world. But really looking at the certainty matrix with the criticalness of that assumption that you're making to the success of your innovation or your idea.
Another question is how to measure the market opportunity and what questions should you be asking a participant about adoption without biasing your response?
Yeah, asking questions is hard though. So that's where it really is about observing and understanding, because it gets back to that say do. I can say, particularly if I'm face to face with someone, that, oh, sure, I love your idea. That's great. I will definitely pick that up. But it's understanding how you can creatively, again, create an environment that has your product or service in context, whether it's online, creating that digital storefront as a lo-fi opportunity for you to start to see how much engagement and awareness and excitement you have around your idea, to placing it in the real world where they would encounter it, whether it's at the mall or inside a store shelf set. So asking people how they feel can be very challenging when you're trying to understand the market opportunity. You can start there. There's always a great place for you to start, but you want to start to build that confidence in understanding human behavior and what they would actually do in context when you're starting to formulate those thoughts on the market viability. I don't know if Michelle and Lennon had any other thoughts.
I think just I think what you said about a digital storefront, I mean, I've seen some really interesting and clever ways of using things like Google Ads, where, you know, it doesn't lead anywhere other than a thank you so much for your time and answer a couple of questions, but just getting some of the metrics around who actually clicks on this versus, you know, a benchmark. Those are really clever ways of sort of a market sizing activity or prototype.
There was also a question that came in about how can you use virtual reality to incorporate into the prototyping process and the testing process? Any thoughts there?
Wow.
Yeah, I love using VR. Go ahead, Lennon.
No, if you've used it, I mean, it's actually a really good question because we have a virtual reality lab here. I have not used it. I don't know if Giustina, if you have any, I mean, I would think it'd be some type of immersive experience. It'd be a great tool to use for live prototypes when you want to test out layout of a new product. Yeah, that would be a great part. I think one of the hurdles of VR is, I mean, if people are aware of some, I think it's just still a really early tool. We've even looked at it for other applications, and I think it's just the development time right now. I think we're just kind of in the early stages of it, but I could definitely see it as a more useful tool for more live prototypes, and even with a technical prototype. I mean, understanding how the user interacts with it. I mean, some of the examples that Michelle said, more on the human side of it, would be very useful.
Yeah, I've used it in the past to create that store experience. And the wonderful thing about VR too is you have the eye tracking ability, so you can actually see what people are looking at. So I found that to be really powerful in the context of live prototyping, but still not putting it in a store. It's also helpful too if you have an innovative and creative idea that you don't want to actually put on a real store shelf, because it might be still so proprietary and so new, and you're worried about that VR can start to bridge that gap between actually having it out into the real world, but also wanting to understand the effect that context can have on the success of your launch. So I've seen it from a context perspective, being able to start to understand what people see, what they're looking at, how they interact, and then also, as Lennon alluded to, how you can actually interact with that product or that service. It can be really powerful.
I want to add one more thing here, which is, if one of the points of prototyping in general is to be able to experience something and have a common understanding of something, VR is an amazing tool for that. So to put on that headset and to, especially for like environments design or space related things, to be able to put it on and actually all experience the same thing at once, that's a super powerful tool. The one caveat I'll give here is VR allows you to visualize something that is very, will seem very developed or very done, potentially, and do that a lot earlier in the process. And there are pros and cons there, right? So the pro is we all can agree that, an experience and see it all together a lot earlier, we can make tweaks. The downside of that, or the watch out I'll give, is that when you get feedback on that, the feedback you get might not be as pointed as you'd like. So you might get feedback about, the lighting or the, whatever else, and not be as focused on the actual thing you want feedback on. So I think it's just a reminder to pick the tool based on the kind of question, or pick the way of prototyping based on the kind of question you have, and be very specific about how you prototype, in addition to that aligns with the question. If that makes sense.
Michelle, I'm going to go to some questions that are coming in about the MDI program itself. So I'm going to maybe combine a couple of these. So one question about, is the program full-time or part-time? Can somebody from industry take it as a part-time offering? And then another question about if there are any recent examples of items or things that have been designed by the MDI program.
Yeah, well, and so I'll start us off, but I also want to lean on Lennon and Giustina, because I should have said both Lennon and Giustina teach some seminal courses in the program as well. So jump in. So right now the MDI program is a 12-month full-time program. We know the needs of a working professional, and we hear you, that sort of version 2 that hopefully we get to in the future. So version 1 was, summer start program. That means for this next year, that will be May 17th on through to the following May, and then you have a Master's of Science. So examples of what folks have designed. So Giustina, I'll ask you too, but Lennon and I are teaching a capstone course right now where students are designing some digital tools. So one team, let's see, I'm trying to remember from this morning. One team is looking at sustainability as a way, as a factor for purchasing items. So thinking about, when buying clothes specifically, how much CO2 and water and all of these things actually get used, and using that as a sort of starting to visualize that and compare that to other purchases, and potentially do some interesting things around carbon offsets and things like that. Another team looking at an event, a community event in a physical space, and how to tie that in with a digital experience, and how to make that really benefit that specific community that event is held in. Giustina, you had a couple of others from last semester. I don't know if you want to.
Yeah, we partnered with Make-A-Wish of Wisconsin to look at how, particularly in COVID, how it seems funny, not nonprofit to be in the business class, but we were trying to understand the fundraising and how their fundraising business model was disrupted. They did a lot of face-to-face events and help support and understand their processes at Make-A-Wish, and how might we think creatively about disrupting that and changing some different ways that they were able to fundraise through the program.
I skipped over this, but I should probably say that MDI is a collaboration of those 5 schools and colleges we mentioned, and the core coursework as part of that program really gives students an overview into each one of those different perspectives. So we have an intro design thinking class that's in our School of Human Ecology. We have a what I call skills building, or sort of fundamental skills classes of sketching and drawing, and also Lennon teaches a class on physical making in the maker space. So students get really like on every machine, and they get they build kind of that maker skill set. We have Giustina teaches the business design, or sort of design thinking through a business lens course. And then our capstone classes are really where projects bring it all to life. So that arc, and I think that diversity of coursework, along with students' electives in all of those schools and colleges, really help students get a really broad understanding of design thinking and human-centered design as they go through.
Yeah, I could just chime in a little bit, because I think one of the things related to prototyping too that makes the program interesting, and it's also related to something we have talked about, is that when we normally teach a design class, students use a set of tools that are needed to solve that specific problem, but usually they're somewhat limited either by the facilities they have, or even usually more the case what tools they're aware of. I think the virtual reality is a good example there. Is that if you've never used virtual reality as a tool, you may not grab it from your toolbox. So we have a course called Tools for Prototyping and Manufacturing, and it's one of the core courses, and it really tries to teach a wide range of tools. And actually, in some of the pilot courses we ran, we did include virtual reality in that as one of the tools that we had. But there's a wide range of tools, from 3D printing to other computer, like laser cutters and others. They're mainly computer-based prototyping methods we teach. But even up one layer, I mean, the program I think is unique is that a typical master's degree is a lot about depth. And if I were to pick a depth area for this program, it's probably design thinking, which is what we're talking about now. But I think one of the most unique things is that this program is a lot about breadth. And so students from a wide range of backgrounds come in, and we really have created this program that allows them to learn a wide range of tools. So it's much, much less about depth and much more about breadth, which is pretty unique. And then throwing in the interdisciplinary thing supports that idea and makes it even more unique.
So I want to go to a specific question that's come in about one of the slides that was shared. So referring back to the line graph at the beginning, I think, Michelle, this might have been during your portion, the 3 stages of inspiration, ideation, and creation. A question about what does the lower or the second line on that graph represent, and why are there 2 lines? So I don't know if maybe we can pull back up that slide.
1 minute.
Yeah, if you want to start talking.
I think it was like where you converge and diverge.
Yes, yeah.
I don't, it was meant to encapsulate sort of the breadth and going broad, just turned sideways. So I think it was, it went in tandem with the other line as sort of an opening up and then a closing down. And in general, in inspiration phase, or when we're learning, we are going broad. Yeah, so that bottom line, exactly. So it's it's not really a graph. It's just meant to say, as we go through, we're opening up, we're learning as much as we can about the people and the interactions and the challenge that we're trying to solve. And then at a certain point of saturation, so you say, we feel like we're hearing the same things over again, or we have got enough to work on or work with now. the synthesis process and saying, okay, what's important? Let's dwindle it down to just the top things we need to take away. That's the converge process again. And then similarly in the ideation phase, you say, okay, now that we have the top 5, top 7 things we really need to focus on, let's open that up to any idea that we can possibly think of, whether we can make it or not, or whether it's, a feasible thing or a viable thing. Let's just throw it all out there. And then when you have enough of that, you say, okay, let's pick the top ideas or combine ideas to really get down to a set that we can take forward and prototype. So the bottom line means nothing other than just, kind of in tandem with the top line opening and closing in that diverge converge process.
Great. So we have a number of questions, and maybe this can be the one that we end on. But going back to this idea of intangible, maybe like you're not designing a product that you want to sell. So one question about like, could you still prototype for something like a brand or a logo or something that's consumable? Or there was another question about like, what if it isn't a product or a service, but someone's asking about more internal operations, like an organization's post-COVID workforce environment, working from home, that sort of thing. Any thoughts?
Yes. Yes, you can use it for all. It's just like taking out a piece and having somebody experience in it. So yeah, we've seen design thinking applied to business operations, HR processes. It's all about just understanding your person you're designing for. So in this case, it could be the employee post-COVID. So you gather the understanding, what problem are you trying to help solve for them? And then creating different situations where you can maybe provide different tools for them. But that's a prototype. When you're giving them different experiences, you're designing an experience. And that really is where the opportunity is. Instead of just saying, would you like it if your computer monitor was, you had 2 computer monitors at home? Actually do it. And then you can understand, once you place it in the real world and you start to have that interaction in that context, what is actually going to happen. So yes, you can use it for all of the above. That's what I love about design thinking. You can be so creative. It really is just trying to get something, anything into the world for people to experience, whether it's a product, a service, or a process that you're trying to implement. Instead of going 100% changing it for everyone, a prototype is simply just having a few people interact with something, really, and you can kind of build on that fidelity as you start to scale and move out to other parts of the organization. I don't know, Michelle, if you had anything to add, but yes, you can be creative and use it. That's why I love this process.
Yeah, I'm just going to confirm a lot of what you said, Giustina, and say, one of the points of a prototype. So I think talking about something goes so far. What do they say? An image is worth 1,000 words and a prototype is worth 1,000 images. Something like that. I probably got that wrong, but that is true, right? So if you talk about something, or you just sort of look at a still of something, you can get so far. But if the point is actually getting into more of the experiential aspects of something. So for a return to work situation, that might be as simple as, setting up 3 different floor plans and having people look at that, or 3 different sort of mock-ups of a desk. It could be, you take it to the next level and actually do a video of a couple of different options, so someone can watch a video. So it doesn't always have to be, a live thing. You can mess around with what medium you use to actually get someone to experience it. But the whole point is they experience it rather than just hearing about it or discussing it. And so whatever you can do to add that experiential layer is super important. VR, maybe, I don't know.
Lennon, anything to add in 20 seconds?
Nothing else to add. I think they did a great job.
All right, so that's all the time that we have for questions today, but I want to thank all of you, our speakers, for your time today, and everyone who tuned in.